Okay, it should be working. At least looks like it is on this end. And I'm just going over the textbook here, looking at section 1D, looking at two types of arguments, inductive and deductive. So it's got an example here of an inductive argument where you've got something specific, birds fly in the air but eventually come back down. And we hit on what goes up must come down, and the second deductive argument. And so I'm reading over this. Maybe I'm just kind of scanning, and I'm going to take note that I've got two types of arguments here. That I've got inductive and I've got deductive. So maybe I just go ahead and I'd say inductive. This does not like to do that. Okay. And I'd go ahead and I'd write that down, that I've got inductive versus deductive arguments. And maybe I'd come up with another different inductive argument to go with it, like thick books have a lot of words and are really difficult to read. And you could come up with some different counter examples to that and be like, okay, the seventh Harry Potter book, really thick, hard to read, lots of words. The last Wheel of Time book, really big, thick, lots of words, hard to read. And then someone could say, instead of you being like, well, heavy books are hard, they could come up with something that's like, yeah, but what about this giant picture book, like the Big Book of Airplanes? That's not hard. So that's kind of what I'm thinking about as I'm reading through this. We'll try something a little bit different here. Let's add another window capture. Yeah, there we go. But this thing is not working. Oh, this is a shame. It looks like I am just destroying the ability for my computer to run. No? Okay. Sure. Hmm. Uh, I don't know how to make this thing control scroll. Oh. Transform. Fit screen. And fill up the window. Yeah, whatever. Okay. Anyways, we've got those ideas for deductive and inductive arguments. Let's see, maybe if we can jump to some of the homework here. We'll jump to 1E, and we'll take a look at the homework as to think about those inductive and deductive arguments. This is the first time I've tried this sort of streaming like this, and I don't know if it's going to work or not. I don't know if you guys are going to get a lot out of it. I haven't really used this streaming software too much. All right. So let's take a look at some ideas here. Doop, doop, doop. Like number 17, we're looking at explain whether the following arguments are deductive or inductive. So all of John Grisham's books have been superb, so his next one is also bound to be superb. Okay. A little bit of a loaded question because it's a value judgment, but we've got this general idea, all superb. I'm sorry, that says poop. My kid uses this computer too, and he thought that was hilarious. There. Now no one knows. So all superb. Moving to new superb. That's moving from something general to something specific. That is deductive. Counterpoint there is kind of a weak argument, I think. Although if you're saying that they've all been superb, then chances are you're going to like the next one too. So I don't know what to tell you. So you're analyzing inductive arguments. I want to take a look at that. So determine the truth of the premises of the following arguments, then assess the strength of each argument and the truth of its conclusion. So 23, premise. Michelangelo, Manet, Monet, Modigliani, Munch, and Miro were great painters. So painters whose names that begin with M are great. So let's see here. We've got a bunch of people coming together used as examples for something general. So this is number 23 here. So number 23, some people, leads us to a general idea. I'm going to write big idea. That is full-on inductive, right? It's totally like false. Let's see here. Boop, false. I mean, it's a weak argument. I think it's more along the lines of painters whose names we know are great. I think that's a lot better statement of that. Premise, number 24 here. If I eat ice cream, I gain weight. If I eat cake, I gain weight. So the conclusion is eating desserts causes me to gain weight. I can kind of see that. Hey, what did I say about this being kind of a new setup? Yeah, I knocked over everything. So number 24, if I eat cake, I gain weight. Gaining weight. Eating dessert causes me to gain weight. That's pretty true because I think we overestimate how much we can eat or how little we've eaten, that is to say. Desserts contain more calories than we think, so that's true, but it's still kind of a weak argument. It's more like overeating. It's a calorie argument, and they're just saying desserts have a lot of calories. 25. Robins and wrens are birds that can fly. Eagles and falcons are birds and they fly. Hawks and vultures are birds and they fly. So the conclusion is that penguins are birds and they fly. So this is the classic example here. We've got a deductive argument, but it's kind of wrapped up in a it's a really weird one. Let's break this down. So let's break this down here and let's take a look at this. The idea is that we've got specific birds and that says that birds fly. And then all birds fly tells us that penguins fly. Fans of Bloom County and A Wish for Wings That Work, that penguin would know that penguins actually fly through the water. So what we've got here is we've got a list of specific birds with the implication that all birds fly. So we've got these sort of specifics that lead to a conclusion. So this is false right here. Not all birds fly. However, under the conclusion that all birds fly, right, if that was true, then we would know that penguins fly. But it's not. So the problem here is that this is false. It's this middle one right here that's false. All birds fly. A better thing would be to replace fly with have wings. So then penguins have wings. Boom, there you go. And this ties into number 26. So let's take a look here at number 26. Apes and baboons have hair and they are mammals. Mice and rats have hair and they are mammals. Tigers and lions have hair and they are mammals. Animals with hair are mammals. That is almost true, I want to say. I don't know, how do we say that? That it's not quite true. I think there could be an animal out there that has hair and is not a mammal. So I think it's a pretty strong deductive argument, though, because if we have a mammal, it's going to have hair. And that's kind of what 25 was going after, was they said, if I have wings, then I can fly, which isn't true. If I'm a bird, I have wings. True. If I have wings, then I can fly. Ooh, false. So there's one chain in those conditionals that was incorrect. 26 rings true. So 27 and 28 here. The sum of an even integer and an odd integer is an odd integer. That's true. We can go through all this. That's a really strong example. And that's an example of a general statement in math that rings true. Number 28, whenever we multiply two negative numbers, the result is a positive number. That's absolutely true. We can go through that and show that. I want to take a look at 27 here because I am a math teacher. So this is math teacher's prerogative. I'm going to write down what an even integer and an odd integer look like. If a number is even, it's 2, 4, 6, 8. It's some other number times 2. So let's write that down. So 2n. That's what an even number looks like. And then what's an odd number look like? Well, it's not 2 but 3. It's not 4 but 5. So it's an even number plus 1. 2, twice the number, plus 1. 2m plus 1. And we're taking their sum. 2n plus 2m. This is going to be even. Plus 1. Even plus 1 is odd. Boom. There's a little mathematical proof that the number 27 works. Cool. All right. Let's zoom out here. Not take a bookmark. I want to go to the next page. There. Let's take a look at some of these deductive arguments. Oops, I want to search. You know, the old reader used to have a pretty decent zoom feature. Do you think that's something that they'd have to fix? Cool. Evaluate these deductive things here. We'll start with number 30. All fruits are foods with sugar. Chocolate bars contain sugar. Chocolate bars are fruit. So this is, we want to take a look at, say, whether this is a valid argument and then whether it's a sound argument. So if something is valid, then that means that what we're looking at is true. Like, it would make sense if it was true. If it's sound, then that's what's saying, okay, and now everything is on the up and up, let's say. Perfect. So let's see here. Are all fruits are foods with sugar? So this is our fruit. And then right in here we have sugar. And inside of that is chocolate bars. So that's what we're looking at, and we want to figure out, is this valid? Is this sound? What is this? I'm going to jump back here, and we're going to go back to chapter 1. We're going to jump to sets and Venn diagrams here, and oops, not sets and Venn diagrams. We're going to jump back to that other page and take a look. And this is part of what, like, analyzing arguments. This is part of what reading the textbook is. we read through it a little bit. We did some problems, kind of unsure about if this is valid, sound, whatever. We talked about evaluating an inductive argument, talking about its strength, cool. And right now we're looking at these deductive arguments and saying, is it valid, is it sound? And this is it right here, evaluating a deductive argument. We apply two criteria when evaluating a deductive argument. First, it's valid if the conclusions follow from its premises. So our argument about the candy bar was valid. It's sound if it's valid and all its premises are true. So is a fruit defined by like having sugar, which I think is, no, that's not true. That's not true at all. So this is not sound. All right. Let's take a look here. Bloop. I want to jump to assignments. Let's take a look at some of the homework problems here. We'll jump into those and talk about them. And add a window capture. Do homework. Perfect. There we go. Well, fantastic. All right, so let's do some homework. Decide whether the following statement makes sense or does not make sense. So my inductive argument provides absolute proof of your client's guilt. This is an interesting one. Does not make sense. We talked about this with inductive arguments. An inductive argument cannot prove that a statement is true. So that's something we have to keep in the back of our mind. Decide whether the following statement makes sense or does not make sense. Through the logic of deduction, I will show you that if you accept the truth of my premises, you must also accept the truth of my conclusion. That is deduction. In a valid deductive argument, the conclusion follows necessarily from its premises. Yeah. That's what deduction is all about. Let's jump to some more of these ones I was talking about. Assess the strength. See here. Lions and cows have 4 legs and are mammals. Totally true. Chipmunks and elephants have 4 legs and are mammals. Totally true. Squirrels and dogs have 4 legs and are mammals. Totally true. These are our 3 sets of conjunctions that are all true. What about the conclusion? That iguanas have 4 legs, so they are mammals. The arguments are moderately strong, but that conclusion is totally false. It doesn't follow from the arguments. Yep. Better would be, mammals all have 4 legs. That's a better one. Not if I have 4 legs, then I'm a mammal, but if I'm a mammal, then I have 4 legs. The converse. We talked about converse in the last section. That's a lot of what happens here, is mixing up the statement with its converse. Determine the truth of the premises of the following arguments. Even and odd adds to odd. Bloop, bloop, oops, bloop, bloop, bloop. They're all true. Yep. Argument is moderately strong. Conclusion is true. Yep. Like, it's not proof. And I gave the mathematical proof for it. We talked about this one too. Now we take a look at these. I think you guys can work on these test problems. These are pretty cool. So this here says for all positive real numbers a and b, the square root of the sum is equal to the sum of the square roots. And it's got an example here, a with 1 and 4. So what that's looking for is, let's see here, bloop. And make that go away. Perfect. That is looking for something like this, where we take and say the square root of 1 plus 4 is the square root of 5. The square root of 1 plus the square root of 4 is 1 plus 2, which is not the square root of 5. 1 plus 2 is equal to 3, which is the square root of 9, right? So 1 plus 2 is greater than the square root of 5. So that totally doesn't work out. And there's the rest of those that you can sit and go through. That covers section 1D. All right. We've been going for half an hour here, I guess. We've been live for half an hour. I'm going to edit this, I think, if I can. I'm going to pull out a lot of this dead air and clumsiness, if I can do that. I haven't used the YouTube stuff for it. Hopefully somebody gets something out of this. I haven't been watching like the channel or anything, which I probably should be in case someone had questions. No, of course, no one had any questions. I'm looking at it now. Yeah, perfect. I'll check the resolution, which is not optimal. Interesting. All right. Yeah. I am going to talk with you later then. All right. Bye.